This question is the final one in the algebra paper, the NZQA paper from 2012, and it asks us to find the possible values of D if real solutions exist for this equation. So we're thinking if real solutions, as soon as it mentions this, we're talking about the discriminant. So we want b squared minus 4ac. Now it says real solutions, so because it's a plural there, we'd be anticipating that it's going to be greater than 0 and that we'll head for 2 unique solutions. But it could possibly be greater than or equal to 0, but because it says real solutions in the plural, we'll go with greater than. Now because we need a, b and c, we need to expand this because I can see there's some x squareds here. So we'll need to collect the x squareds together so that we can make sure we get the correct coefficient of a. And we'll also want to make sure that we've got all our constants collected together to get the correct value for c. So we'll start with that. So expanding this out, we'll get x squared plus 5x minus 1 minus dx squared minus d equals 0. Alright, now we know we're looking to collect our like terms together, so we'll have, if we collect the x squared terms, we'll have x squared 1 minus d. There's only the single 5x term there, and then the constants to collect together, so we'll have minus 1 minus d equals 0. So I can now see that this is a, and we've got b here, positive 5, and we've got c here. So now we're ready to put this into b squared minus 4ac. So we've got 5 squared minus 4 times 1 minus d times negative 1 minus d, as I put each piece into the equation. And we could take out a common factor here of negative 1. So, oops, we want that to be greater than 0. And so we could now say 5 squared, taking out the common factor of negative 1 and multiplying it into here, we'd have positive 4 times 1 minus d, 1 plus d. Now if you didn't see that, that would be fine. It just makes some of the algebra simplification a little bit more tricky because you have to worry about your negatives and positives and slipping on a sign. Obviously we'll still have to here because there's a negative, but we've reduced the possibilities. So we have 25 plus 4 minus 4, whoa, no we don't, plus 4 times 1 plus d minus d squared being greater than 0. Okay, and 25 plus 4 minus 4d squared. Okay, still greater than 0. And now we have 29 minus 4d squared is greater than 0. And we can now solve for our values of d. So we could say 29 is greater than 4d squared. D squared is less than 29 over 4. And if we work out these values of d, so we're kind of looking at endpoints again. So 29 divided by 4, 7.25, and then we want to take the square root of that. So d endpoints, if you like, just because we're solving it as if it was a quadratic. So endpoints at d equals, taking the square root of 7.25, so we're at positive or negative 2.69. Now, we don't know from this equation whether we're talking about a parabola that's a positive parabola or a negative parabola, because we don't know this value of d in the first place. So 29 minus 4d squared, when we're looking at it, we can't really tell so easily. But because of this minus 4d squared, we're guessing will be an upside down parabola cutting through somewhere like this. Now we could try it out by just checking a few points as well. So we could say, okay, if this is positive 2.69 and negative 2.69, if we were to try, say, the value of 3 into the equation, would that give us a positive value or a negative value? And if we took that value of 3 and we substituted into here, 1 minus 3, we've got negative 2, negative 1 minus 3, we've got negative 4. So negative 2 times negative 4 is positive 8. So we've got 25 minus 32, which is going to be a negative value as the negative parabola would suggest. At the value of 3, we'd be looking for a negative number. So we're looking for this statement to be greater than or equal to 0. So we're looking for this part of our parabola, which means that D has to be between positive 2.69 and negative 2.69 in order to give us an equation up here that comes out greater than or equal to 0, and in other words has real roots. So we're solving it as if it's a quadratic, finding our endpoints, and then using some information that we can see within the question to give us a negative parabola, and or testing some points on either side to see that we've got our parabola up the right way. And then once we've selected the correct part, then we can give the correct set of values that would make the equation true.